Uh,
Enough?
some, yeah. Today is 12/12. That's neat. 12/12. I'm just going to write the year because I think it's neat that it has all those twos. 12/12, 2, 1, 2, 1, 2, 2, 2. What a neat date. And yes, Maddie's exactly right. 12 days from now, it will be Christmas Eve. What's that all about? I did buy one gift. I can't say what it is because it's a secret, but yes, I did buy one gift. So today we will be solving radical equations, and this is not a one-day endeavor. This is a several-day endeavor. And if you think we've done this before, you're right. But when we did it before, we did the easy warm-up version. And so I'll give you just a quick kind of off the script example of what a radical equation looks like. And the ones like I'm about to show you, again, we did these back like a month or 2 months ago or something. And then when we did that, I had alluded to the fact that they're going to get a lot harder. And today's that day where they get a lot harder. So as a warm-up example, you'll remember that we saw equations that looked like this. We had like the square root of 3x minus 4 equals, I don't know, 5. Right. And you remember these were really, really easy. And they had a certain characteristic about them that made them easy. And that characteristic is that there's just a root equal to a number. I mean, easy. Do you remember how we solve them? Got to get rid of the root. How do you get rid of a root? You square it. Very good. So remember, the inverse of a square root is a square. So I apply a square to each side. I can do that. That's legal. What do I get on the left side? What do I get on the right side? And then to solve, it's like a 6th grade equation. Now I add 4 to both sides. I get 3x equals 29. I divide by 3, and I get x equals 29/3. And you remember, of course, that with these, we always have to check our solutions because sometimes we would get problems where we didn't do anything wrong, but the answer turned out not to work. And so it doesn't take long. Follow the green arrow here. If you take this number and put it in place of that x right there, just some basic math. What is 3 times 29/3? 29, of course. The 3's cancel. And what's 29 minus 4? And what's the square root of 25? And 5 does equal 5. So we say you're a solution, and then we move on to the next problem. You remember this, right? Okay, so today's problems are more difficult than this. And so there's several reasons for that. In the first example that we're going to look at, what's going to happen is, well, I'll let you see for yourself. So our first one is the square root of 6 minus x equals x. The idea, like the what do I do, doesn't change. It's what happens after that becomes more of an issue. So what do we do? Square both sides. Like, I'm ready. I got to get that. You got to get the square root to go away. You got to kill the root. And so when I square this left side and I square this right side, what do I get on the left? Yeah, you just get 6 minus x. And what do we get on the right? Nice job. And you'll notice now that this is not a 6th grade equation. This is far from a 6th grade equation. This is a high school level equation called a quadratic equation. And to solve a quadratic equation, the first thing we always want to look for is, can I pull everything to one side, set it equal to 0, and fingers crossed, can I factor it? And so that's what I'm going to do here now. Is to solve this, I need to pull all of the stuff over to the right-hand side. And do you know why I would take like this guy and this guy and move them both to the right when I could just move one thing to the left? Why would I do that, Brady? Always keep the x squared positive, right? And so if x squared is on a side, I don't care if it's right or left. And if he's positive, you remember this, we did this before, then we want to leave him alone and pull all the other junk to him. So I'm going to leave the x squared where he's at. And then I'm going to pull the minus x over, renaming him plus x as I do. And then I'm going to bring the 6 over, renaming him minus 6 as I do. And now it's all equal to 0. And you'll not encounter any real upper level factoring stuff today. This is all pretty light work. So as I factor the right-hand side, I remember that factoring looks like this. And I'm looking for two numbers that multiply to make -6. And then the middle two and the outer two have to add to make +1. What am I looking for? So if I put in a +3 and a -2, and for anyone who might be a little bit rusty in need of a quick review, always remember for factoring the blue and the green. And you may not have the benefit of colors in your notes, but you can still just go back, flashback, and remember that's what makes this tick. Like, I'm not going to give you any stickers and attaboys for figuring out that 3 and -2 make -6. It's that middle part, remember, that we don't control. And the 3x from the center blue and the -2x from the outer green add to make +1, which is what we want. So what are the solutions then to this equation? X equals -3 and x equals +2. So I hesitate at this point to call these solutions. I'm more inclined to call them candidates because I have to vet them. I have to make sure that they're legit, that they work. And so we're going to go back now to the very beginning of the problem, and we're going to plug these numbers in one at a time. So I'll color code this for you. I'll do blue first. And so -3 is going to be my blue candidate. So as I do that, and I go back up to the top, if I rewrite the equation, it'll say the square root of, what does that say? 6 minus x. So I believe that is 6 plus 3. And then on the right-hand side, where I have x, I'll put -3. And 6 plus 3 is 9. What's the square root of 9? 3. And 3 does not equal -3. So that candidate, x equals -3, gets a cross out. We've been down this road before, kind of in a different context, but I want you to commit to one of two things. Don't ever just leave a candidate just sitting there. Do one of two things. Cross it out if it's extraneous, no good, or box it or circle it if you've tested it and it's good. So he's committed now, out. -3 is out. Let's test 2. So for this, I'll use red. This will be my red work, and I'm going to put 2 back up in place of the x's in the original problem. So this one would say the square root of 6 minus 2 equals x, but I'm going to put 2. What is 6 minus 2? Square root of 4 is 2 equals 2. So this one can get a box. It's a solution. So the answer to this problem is only x equals 2. We found 2 candidates, but one of them proved to be defective. Good so far? Okay. Any questions about that one? All right. Next one. We have x minus 4 equals the square root of 26 minus 5x. I haven't said this out loud yet because it's not always going to make sense, but you really want to make sure that the root is by itself, meaning, if possible, that there's no one on the same side with the root. And in this case, it's like, well, that's already done for us. So we're ready to proceed. What are we going to do? We're going to square both sides. Those lovely 3 words, square both sides. And so on the left side is going to be a square, and on the right side is going to be a square. And I am, as they say in the business, firing off a warning shot. Here it comes, firing one right across the bow. Ready? This is where it happens. This is where the mistakes happen. So watch out. Let's do the easy side first, the right side. What do I get when I square the square root of 26 minus 5x? 26 minus 5x. You just lift the root off, right? Thank you. Appreciate that. The left side. I wish in an 11th grade math class, this is an 11th grade level by definition math class, I wish this were not the source of the mistakes, but it is. And if you struggle in the next 3 or 4 days of my class, I assure you it will be because of what's about to happen. Who can tell me what x minus 4 squared is? I wish it were x squared plus 16. My job would be so much easier. It's not x squared minus 16. I'm telling you, this is, I literally have it written on the board. It's x minus 4 in parentheses squared.
Oh, wait.
Yes. So what we're going to do now is we're going to take a couple of minutes and here comes the danger zone. I'm trembling. You just can't see it. Option number 1 for you for the next few days is this. This is your bailout method to say, I'm going to take x minus 4 and I'm going to multiply it by itself. I'm going to do what Brooklyn said. Squaring something means to multiply it by itself. And it's at this point that you'll soon see the egregious nature of the answer x squared plus 16. It's what a normal person would or should say, but it's terribly wrong. You'll see. So let's do x times x. What do we get? And let's do negative 4 times negative 4. What do we get? But I want you to take note of the fact that that's just a part of the process, right? How dare we assume that that's all we have to do? When you multiply binomials together, there's an entire process that's going on. I also need to do negative 4 times x. What is that? And I also have to do x times negative 4. Remember, everyone in the first parentheses has to be multiplied by everyone in the second. And what is 4 or x times negative 4? Negative 4x. And so now I'm going to ask you again, what is x minus 4 squared? I'm ready. I'm going to write it right over here. Of course you could. Good. I just take it, leave it, call me crazy. I don't care. This is where you will struggle if you do. That's it. That's it. And I want to show you that there's another way to do that as well. These sweet words, 4 words, square, square, multiply, double. You've heard this before. And so I want to go back and revisit the act of x minus 4 squared because there's a quicker way to do this. Are you ready? Here it goes. Here's x minus 4 squared. I don't like to show this much work. You can. I don't like to. I'm going to remember that to square something, there's a process. It's square, square, multiply, double. So I'm going to color code these for you. I'm going to color code. I'm going to name this guy the blue guy. And I'm going to name this guy the red guy. You ready? Square, square, multiply, double. What is the blue thing squared? What is the red guy squared? Now, this is it. Multiply, double. This is not, by the way, difficult. I don't know why people make it difficult, but it's not. Square, square, multiply, double. Now take the blue thing and the red thing, multiply them together. What do you get? Negative 4x. Double that. What do you get? And that is how quickly you can do that without showing all of that work. Square, square, multiply, double, or else you're going to get in trouble. Something like that. Every single time there's a binomial, like 2 things with a plus or minus, and you have to square it, it works every time. Square, square, multiply, double. Let's practice a few of those before we press on. That skill is going to prove to be the difference between those who get A's on the next quiz and those who get D's and F's. Can you execute that basic algebra? Let's try again. Let's say I had x plus 10 and I want to square it. What do I get? You should be a part of this conversation right now. We get x squared. And we get a what at the end? Plus 100 at the end. I agree with you. Notice I left a space for the multiply double. What's the multiply and then double going to be? Plus 20x. Very good. Okay, let's practice again. I couldn't agree more. But I'm telling you, take it from the years of experience, this is where the you-know-what's going to hit the fan. So, again, if you want to write it out every time and go 3x minus 4 times, you go ahead, not me. What is 3x squared? It's 9x squared. What's negative 4 squared? Positive 16. I'm telling you right now, the thing you put in front and the thing you put in back, those are always going to be positives because you're squaring things. Now, in the middle, what do you get? Minus 24x. Good job, Pablo. And again, where does that come from? If you're sitting here and you're too embarrassed to ask, if you're one of those people, I took the blue thing and well, Pablo did, and the red thing, and I multiplied them together. What do we get? You get negative 12x. You double it, you get negative 24x. So you'll see that I'm going to start using that shortcutted process. You're not going to see me doing a lot of this out because I don't want to. Remember those words, square, square, multiply, double. Let's press on. Let's get back to example number 2. So over on the left-hand side, we successfully executed our squaring, and now it's a quadratic equation. So are we going to move everything to the left or everything to the right? Definitely to the left, because the x squared says, look at me, I'm positive and I'm on the left, leave me here. All you other chumps, you come my way. So x squared says, I'm just going to stay here. And then everyone else has to come over. So I'm going to add the 5x across, giving me minus 3x. I'm going to subtract the 26 across, giving me minus 10. And there we are. It's a factoring problem again. So I'm going to factor it down like this and like this. Good. What are my factors going to be? X minus 5 and x plus 2. Very good. So what are my candidates? X equals what? And x equals. Good. And before I go crossing things out or putting boxes around things, it's imperative that I take a moment now and plug them back in. So let's test 5 first. Go back to the very top of the television up there and change the x's that you see into 5. What would the left side say? 5 minus 4 is 1. And on the right-hand side, put 5 in place of that x. What's 26 minus 5 times 5? 1. Square root of 1 is 1. 1, last I checked, equals 1. So I'm going to put a box around x equals 5. So you passed the test, man. You're in. Let's test negative 2. On the left side, what's negative 2 minus 4? And on the right-hand side, if you put negative 2 in there, you wind up with 26 minus 5 times negative 2, which is 26 plus 10, which is 36. The square root of 36 is 6. Negative 6 does not equal 6. He's out. We get one solution. Sometimes you'll find with these quadratic ones that you get one solution. Sometimes you'll get 2. They both work. And sometimes you'll get no solution. They both might not work. Yes, sir. Are you referring to this? That's just part of the process, bro. Everything below this blue line and above this blue line, this is all process. That's our work. Got it? Okay. Let's head to the next one. This is I think, where I get a little bit scared. So I hope I'm just being overly dramatic and that you guys are like, this is easy. So a while ago, I said something about getting the root by itself. You can see that that's going to be a problem here, right? Because there's 2 of them. So if you're a good note taker, I want you to write this down. You ready? I'm going to just speak and you're going to write it down. You ready? If there's 2 roots, put them on opposite sides. Just trust me that our lives are going to be easier. You'll see what I mean. If when there's 2 different square roots in the problem, you want to keep the equal sign in between them. You got to keep those chumps separated from each other. Clear? Yeah, man. Then you move one. That'll be the last example that we do. I made sure there was one of those in the notes today. Okay. All right. So mission accomplished. The roots are on opposite side. It's time to proceed. And in order to make this work, we now have to do something very uncomfortable. And there's a 91.263% chance that you're not going to like this step, but we have to square both sides. Are you ready? Let's get the easy one out of the way first, the right side. What happens when I square the right side? Yeah, you just take that root. Everyone's like, yeah, I love that side. You're not going to love this side. Not at all. Ready? All right. When we square the left-hand side, it's going to be a square, square, multiply, double problem. And so I want you to think of, I'm going to go back and color code it, and I'm going to call this blue guy. Might be worth it, honestly, for you to invest in a couple of colored writing utensils, trust me, and start naming them blue guy, red guy, blue guy. Don't care. Something, get different colors. Green guy, purple guy, I don't care. But trust me, it helps. So when we square blue guy, we're doing square, square, multiply, double, because that's what we have to do. When you square blue guy, what do you get? Yes. Square the red guy, what do you get? Yes. And of course, there's the inevitable space in the middle for the result of multiply double. Square, square, multiply double. Those words are going to become stuck in your head. If you multiply the blue guy and the red guy, what do you get? Don't make a math problem out of this. When you multiply the blue guy and the red guy, what do you get? Good job. You get -1. I'm going to write this off to the side here. You get -1 times the root of -5 minus 2x. That's not even really a math problem, is it? You're like, okay, so you want me to multiply them together, i.e. just stick them together? Yeah, basically. It's about all you can do. But now you have to double that. What do you get? Let's say I gave you 4x. What's double 4x? 8x. Let's say I gave you -2y. What's double that? -4y. So, I mean, just think of this as I have -1 times a thing. Double it, what do you get? You get -2 of the things. Very good. There's almost zero probability that you walk away from that first time and go, oh, that made perfect sense. It's a little rough. It'll get better. So let me color code this for you. Underlining in blue, this was the blue thing squared. Underlining in red, this was the red thing squared. Underlining in yellow, this was the result of multiplying the blue guy and the red guy and then doubling what we got. You see a problem with this? There's another root. He survived. But the good news is we only have one now. In the beginning of the problem, we had 2. Now we only have 1. So our job now is to move the root to his own side and get all of the other junk to the other side. So let's do it. Our focus right now is going to be this. I want to leave the yellow underlined part by himself. So here we go. I'm going to leave the -2 times the root on the left side. I'm going to add the 2x across to give me positive 1x. I'm going to do some basic math here. I'm going to put little circles around this for your educational convenience. There's a -5 and a +1, which are, of course, like terms. What is -5 plus 1? And then I'm going to add 4 to both sides, which is going to give me +1. Still good? I wish I could get rid of this -2, but trust me when I tell you that I don't want to. So now it's time to square both sides again. So we're going to square the left side and we're going to square the right side. I just would feel better if I just write this step down and then ask you in a moment, do you understand how I got that? On the left-hand side, I'm going to get 4 times -5 minus 2x. Now I'm going to ask you, do you know how I got that? I squared the -2, got 4. And then I squared the root and just got some parentheses. And I need the parentheses, of course. And then let's practice now. Square, square, multiply, double on the right-hand side. This ought to be light work. X plus 1 squared. What would you say? Bless your heart for saying plus 2x. Good job. And you can see now that we're almost there, right? All the radicals are gone, and now it's just a very, very basic beginning of the year algebra 2, end of the year algebra 1 problem. It's a quadratic equation. No more roots. Let's just pile all the crap on one side. Fingers crossed that we can factor it, and then we'll have our answers, or at least our candidates. So obviously we want to go to the right side here, but before I do that, I want to distribute this 4. So the left side is going to be -20 minus 8x. And now everyone's free to move about the cabin. So I got this. How many x's will I have? I added 8x to both sides. Bless you. And now I'm going to add 20 to both sides, and it's going to be plus 21. And just like that, after all the mess, it's this that emerges. Beautiful. And this is easy peasy factoring. What are my factors going to look like? +7, +3. So what are my answer candidates? Good job. Do they both work? I don't know. Does one of them work? I don't know. Does neither of them work? Oh, the only way I'm ever going to know is by testing them. So let's go back to the beginning now, and let's test -7 and let's test -3. You need to go all the way back to the beginning, which I believe is up here. So I'm going to do some erasing now because this was all work that you've already put into your notebook. And the original problem now is viewable to you up there on the board. So if I change, which one do you want to check first? Let's check -7 first. So this will say the square root of -5 plus 14 minus 1 equals the square root of -3 plus 7. This is just basic math. You should know by the time you hit an 11th grade math class that minus a negative becomes a plus, right? We should be past little issues like that. What is -5 plus 14? It's 9. And what's the square root of 9? And 3 minus 1 is 2. And then on the right-hand side, what's -3 plus 7? Square root of 4. So I believe that x equals -7 is a champ. I'm going to go ahead and box that guy up. Say thank you. Good job. You work. Now we're going to test, I believe the other one was -3, correct? So we're going to do the same process again. The left side's going to say the square root of -5 plus 6 minus 1 equals, and then the square on the right side, we're going to have -3 plus 3. So what's -5 plus 6? Square root of 1, 1 minus 1. -3 plus 3, square root of 0. 0 equals 0. Therefore, we have 2 solutions. They both work this time. And we only know that because we tested them. I'm trying to rule out any misconceptions you have about things that kids like to say, like, oh, if the answer is negative, it won't work. I don't want you to go down that road. Anything can work. It's up to you to check it and make sure that it works. Good. You still with me? Let's go again. I got an easy one for you. This one is going to be, that one on the difficulty scale, that one's about a 9. This one's about a 4. So we're going backwards here. If you survived that and that felt good, then you're home free here. So we have -1 equals -x plus the square root of -4x. What do we have to do? We have to move the x over because those wise words get the root by itself. And it is possible in this case because there is only one root. Remember, if there's multiples, you can't really get it by itself. You can just isolate them from each other. But in this case, if I would just boot that x to the other side, then I'm in good shape. So I have the square root of -4x. And then what's my left side going to say? Well done. All right, let's fly through this one. This one should be comparatively simple because there's only the one root. The double root ones are the ones that suck because you got a square, pray you do it right, move stuff around, square again, pray you do it right. Woo, this is easy. Easy. When I square the left side, what do I get? Minus 2x plus 1. And what do we get when we square the right side? Yeah, you just lift the root off. Good. And now we got to pull all the stuff to one side. That side, the decision's made for us. We want to go to the left. So we're going to add 4x across, giving us x squared plus 2x plus 1. And then we factor. And the factoring for this one is sort of unique. That we know they're both pluses. And the only numbers that multiply to make 1, gosh, I hope they work, are, well, 1 and 1. And it does work. You only get one answer candidate this time. Who is it? X equals -1, -1, -1, -1. So we say x equals -1. You're either going to work and we're going to have one answer, or you're not going to work and we have no solution. Let's find out. Let's go back up to the beginning, which is right here. I'll put a little arrow for your convenience, and let's change all those x's into -1 and try not to make any mistakes. So it's going to say -1 equals, what's negative x going to say? That's actually going to be +1 because it says negative x and x is -1 and the negative of -1 is 1. And then I'm going to put plus the square root of, put -1 in place of the x inside. What's -4 times -1? 4. What's the square root of 4? So we have -1 equals 1 plus 2. And unless they've changed the rules, I believe -1 does not equal 3. Would you agree with that? Therefore, our only candidate proves unworthy of the task. So what do we say? There is no solution. This equation contains no solutions. Good. I would like to start the last example, but I would also like to give you a few minutes to get some work done here. It's not a lot, I know, but this goes back to a question that Brady had asked a while ago. So let's just get this last example at least started. So the idea of get the radical by itself doesn't work, right? Because there's two of them. You literally can't get something by itself when there's multiples. So yeah, and you have a choice to make here. And I hope you agree with, I know if you're still listening, you're amazing. I hope you agree with this assessment. If you move the square root of 2x minus 5, that's not very bright, because you're taking something that's perfectly happy and positive and willfully moving it and saying, I like negatives, so I'm going to move you and make you a negative because I'm a masochist or something. So if you have a choice to make, like one of these roots has to move, I'm going to do what Alyssa said, and I'm going to move this one across the equal sign because it'll make him positive. And 100 out of 100 people surveyed would rather use positive numbers than negative. So when I fix this problem, it's going to say the square root of 7 minus x plus 3 equals the square root of 2x minus 5. And I could give you guys, I realize you're probably massively sick of the sound of my voice. Would you like to finish this problem, or? Yeah? Okay. Remember, this is one of the hard ones. There's no way around the fact. I'm sorry, I don't have any tricks or magic. These problems suck. They're hard. All right, so it's ready to go. Let's square both sides. So we're squaring this entire side. And here we go. Very good. Thanks for getting the ball rolling here. When you square the first part, you get 7 minus x. And then I'm going to put +9, but note that I'm going to put the +9 at the back. You should be used to this starting about now, where you're like, okay, that's right. This is one of those square, square, multiply doubles. I got to leave room in the middle for that poopy part. So now, here's red guy. Here's blue guy. You learned this last time. Please don't make a math problem out of this. Multiply blue guy, red guy, blue guy. What do you get? You get 3 roots. Double that. What do you get? You get 6 roots. So in the middle, I'm going to put +6 roots. I'm sorry about that step. There's just no way around it. Square, square, multiply, double. Right side, there's some good news. That's easy. What do we get over here? Yeah, that's nice. And if we survive this step, then we understand now that our mission is to get the new radical by himself. That one radical will always survive the first attack, always. And so we got him and we're like, I see you right there, you thug. So we're going to move all the stuff that's not a radical to the other side. And so we're going to leave the 6 times the square root of 7 minus x over here. And then again, I'm sorry, this should never be something that vexes us at this level of math. I need to collect and move all my crap to the right. So if I add the x across, how many x's do I get? I get 3 of them. And then join your 7 and your 9. 7 plus 9 is 16. You got to subtract the 16 across. What would you get? Nice. Now we have a choice to make. What is the next step? According to the last example that we did, what is the next step? Square both sides. However, before you do that, I want you to consider something. Do you notice in this case that all of the numbers in this problem can be divided by 3? And I'm not talking about the stuff that's inside the root. That stuff's off limits. So let's do ourselves a solid real quick. And then for the sake of making numbers that are better, less poopy, let's divide everything by 3. So what it's going to look like is right here, I divide by 3. Here, I divide by 3. Here, I divide by 3. And I'm left with this. I'm going to draw a little curtain and head over here to the east side of the curtain. I'm going to have 2 of the roots equal to x minus 7. And now, what do we do? Square both sides. What do we get when we square the left?
4 times 7.
What do we get when we square the right?
X squared. 49 plus 49 at the end. Minus 14.
Bad news is that we probably all want to tear our hair out by now. I don't have a lot left to tear out, but I get it. The good news is there's no more roots, so we're done. Now it's just a cheese puff problem. I do need to distribute on the left, so I'm going to get 28 minus 4x. And the math gods have made the decision for us that we're going to move all of our stuff to the right-hand side because that's where the x squared is positive. We're almost there, guys and gals. So we get x squared. How many x's will we have? Negative 10, so minus 10x. And then what else? And it's time to factor. What do we get for factors? I agree. So what are my answer candidates? That's a heavy, big ask, and we're still not done. I mean, you could just throw caution to the wind and say, you know what? I'm just going to guess. I'm going to box up the 7 and cross out the 3. I'm going to box them both up. I'm going to cross them both out. But why go to all this work and then not see the job through to the end? So we want to now know if those answers are any good. So I'm going to go back now to the very beginning of the problem. I'm going to erase all of my hard work. Please don't erase your hard work. I'm just doing it because I want to keep everything up on the television. And so these are my two answer candidates, and I'd like to know whether or not they work. So I'll color code 3 as blue. Let's test 3. It's going to say 3 equals the square root of 2 times 3 is 6 minus 5 minus the square root of 7 minus 3. What is 6 minus 5? Square root of 1 is 1. 7 minus 3 is 4. Square root of 4 is 2. Does 1 minus 2 equal 3?
No.
Therefore, 3 can say, don't let the door hit you where the good Lord split you. You're out. Let's test the other one, 7. I'll write this in green. So it's going to say 3 equals the square root of 2 times 7 is 14 minus, and then this square root is 7 minus 7. What is 14 minus 5? Square root of 9. 7 minus 7 is 0. 3 minus 0 equals 3. After all of that, we got one answer. X equals 7. Did you make it? When I said that was going to take a while, I kind of knew what I meant was it's probably going to take all hour. I'm going to give you this assignment and understand that tomorrow is, of course, a work day. There's no way we're going home and getting this sucker done. So I'm handing it out to you just so you can physically have it in your possession in case